Welcome back. So today I'm glad you tuned in because this one is going to give you a little bit of extra practice, some examples worked out of how to do some of these stoichiometry problems using dimensional analysis of fractions. Yeah, but it'll give us a little bit more kind of time to look at a couple of these problems and sort of take them apart bit by bit. A couple of things to remember. Whenever we're doing stoichiometry, what does that word mean? That crazy looking yikes thing. The whole idea about stoichiometry is being able to use the balanced chemical equation as a recipe, and in that recipe we can kind of do some interesting stuff. That is a way that we can use to scale up or scale down our reactions to make predictions about amounts of reactants or amounts of products. So one of the key things here, I can't write and talk at the same time, and reactants and products, right? So there you go. The key idea here in order to be able to get these is to kind of use our basic recipe. And the biggest part of this whole thing is that with our basic recipe, we're looking at one key step, and that is this basic one in the middle, the mole-to-mole ratio. That's the big one that we've got to be able to use every single time in our steps as we do that. And where do we get that? That's from our recipe. It's our coefficients from our balanced chemical equation. So let's go kind of dive in and take a look at a problem here and see what this does for us. So here we have a good example of kind of a basic stoichiometry problem, kind of like the ones that we need to be able to do here. This one says how many moles of ammonia can be produced from 2.09 moles of hydrogen gas. So if we take a look at our balanced equation over here, we want to know how many moles of ammonia, that's the NH3, can be produced from 2.09 moles of hydrogen gas. And in this case, we don't really need to use the hydrogen. That's just the way this particular problem works out. So the equation's already given to you, and it's already balanced, so you can take a look at that. Always double check to make sure your equations are balanced because we need that to use for our mole-to-mole ratio. So how I would attack this, I'm looking for moles of ammonia. That's what I'm trying to find. And I've got moles of hydrogen gas, 2.09 moles. So I know that I'm going to be converting from hydrogen to ammonia. So I'd set up my little wonder fraction. I've got 2.09 moles of H2 because that's what's given to me in the problem. Again, that's just what it says here. That's what I'm starting with. So start with what you know. And then the next part is I'm going to convert it using our mole-to-mole ratio. So this part right here was given to us in the problem. Next part, canceling out. I need to make sure that every time I do this, I'm crossing down. So H2 is going to end up in the bottom of my next step, and I'm going to convert it to NH3. Why did I pick these two? Well, the H2 is what I was given, and it has to go away. And I'm converting it to NH3 because that's simply what this particular question asked for. It could be any other compound in the equation, but in this case, like I said, it's NH3. This step right here is going to be our mole-to-mole ratio. That's what we're going to use here, and those come, again, from our balanced chemical equation. So if we take a look at our balanced equation, up here we've got 3H2 and 2NH3, so our mole-to-mole ratio is 3 to 2, or 2 to 3, depending on how you want to write it, but 3H2 to 2NH3, and I'm going to put those directly in here. 3H2 is going to give us 2NH3. And after this point, I'm basically done because the question here is asking me for how many moles of ammonia, and that's what I have here is moles of ammonia because that's our mole-to-mole ratio. So now I can just kind of do the equals part and figure out what my final answer would be to that. So after quickly going and locating my calculator, I now can do the math. That's 2.09 times 2 divided by 3 on the bottom. 2.09 times 2 divided by 3 gives me an answer of 1.39333, some crazy number like that. Yeah, it keeps going. So the final part would be to round it and put units on there. So in terms of sig figs, we look at our original problem. We've got 3 sig figs. So I need to write my answer with 3 sig figs, which would be 1.39. There it is. And then we use units and labels. So our units here is moles, and our chemical is our label, and in this case it's moles of NH3, and that's our final answer for that particular problem. All right, so if you haven't been doing this so far, now is a really good opportunity for you to get out your scratch piece of paper and go figure out how to do these problems. Again, if you don't put the pressure on yourself, watching me do these over and over again, just going to make you feel smart. So I'm going to keep going here. So question number 1, make sure to balance your equation. Every single time. It's the most important thing that you can do, and it's not going to prompt you in the question to do that. So that's got to be a part of kind of your eyeballing it, going, wait, something's not right here. So I'm going to start with balancing my equation. I notice I have 1 oxygen on this side and 2 oxygens on this side. So I'm going to balance it by putting a 2 out in front here, which gives me 4 hydrogens. So I'm going to put a 2 over here, and now we are balanced. So now I can keep going with my problem. So what is the problem giving to us? I'm looking for grams of oxygen. So I'm looking for G, right, of this one. And then I'm looking for moles of water is what I'm given. So moles of water, 0.562 moles of this one. So now you can see the conversion I'm going to do. I'm going to have to go from H2O to O2. And I'm going to have to do this one extra step because this one's asking me for grams. It's not asking me for moles. So when I set this up, I start off with what I am given. And my given is 0.562 moles of H2O. I'm going to draw my little wonder fraction line here. Sorry, it should look like an H. The next part is cross it down. So this is going to be moles of H2O, going to go on the bottom. And I'm going to convert this to moles of oxygen, MOL of O2. Why did I pick O2? Again, because it's what this particular question is asking me about. I've already identified that's what I needed. The hydrogen's there, it just isn't an important part of this particular problem. So now, this is my mole to mole step. And in terms of figuring out what goes where, I look back at my balanced equation. My ratio here is 2 moles of H2O to 1 mole of O2. So I enter the numbers just like that, 2 moles of H2O to 1 mole of O2. Now, I'm not quite done yet. In the other problems, I was done because it asked me for how many moles of oxygen. But in this one, I'm looking for grams of oxygen. So this is a wonder fraction. One more time. And now we're going to use molar mass because moles of O2 can go down here. We can do grams of O2. And again, to remind you in terms of how to do this, this is our molar mass step. We've got mole to mole and the molar mass. With this one, this is the periodic table masses. So we got 16 times 2 is our molar mass of oxygen, which ends up being 32 grams. And again, it's 16.00 times 2 because it's O2, so we got to put that part in there. All right, and I think we're now done. Do our units all cancel out? Moles cancel out, oxygen cancels out, and I'm left with grams of O2, and the question's asking me for grams of O2. So now I know I'm in the right shape. And now it's a matter of mathing it out. 0.562 times 32. Across the top, and I'm going to divide by 2 since that's on the bottom. My handy-dandy calculator says 0.562 times 32 divided by 2 equals 8.992 is my calculator answer. Check for sig figs. Sig figs looks like 3 from my problem up there, so I will write it as 0.99, and I need to use my units here, which is grams, and my label, which is O2. And again, if you're not sure what your units are, look at the last square that you've got. The last top right square is going to tell you what the units are for your final problem. Okay, let's move on to the next one, see how we're doing. Layering on a little bit more here. Get a little bit harder as we progress through this. So here we have a situation where I didn't give you the equation, so you got to write this one out, although these are type 3 compounds. Should be pretty straightforward to do this. So sulfur dioxide reacts with oxygen gas. We've got sulfur dioxide reacting with oxygen gas, and it's going to be producing sulfur trioxide. So let's start by attacking that. And again, the question here, what are we looking at? How many grams of oxygen will be needed to completely react with that many grams of sulfur trioxide? Okay, so we're going to have to do grams and grams here. Still going to do moles to moles in the middle. Start with writing the equation. Again, if it's not given to you, you got to write it. Sulfur dioxide. There's sulfur dioxide. Di means 2, so there's SO2. And it's reacting with oxygen gas. Oxygen gas is diatomic. And then it's going to produce sulfur trioxide, SO3 for trioxide. It looks like sulfate, or sulfite, but it's not. Next question is, so write the balanced equation. Next question, balance it. Got to do it. You wrote it, now make sure it's actually balanced. Is this one balanced? I don't think so. I think we got 1 sulfur, that's good, but we got 4 oxygens and only 3 oxygens over here. So that's just not going to work. So I'm going to start by, see how this works. What happens if I do that? So now I've got 2 there and 2 there. Make my sulfurs balance out. Gives me 6 oxygens over here on the right. And then I've got 1, 2, 3, 4 oxygens, 5, 6 oxygens on the, oh, I'm done. Okay, there we go. So there we have our complete balanced equation. We need that because it gives us our mole to mole ratio. All right, next thing. I'm going to label with what I have. I'm like grams of oxygen. So I'm looking for this. And I'm given that many grams of sulfur dioxide. So that's 3.75 grams of this stuff. So we're going to be doing that conversion. Okay, so, the Wonder fractions, yeah. 3.75 grams of SO2. So just like any other wonder fraction. cancels out, right? Grams of SO2. Well, I can't use my mole to mole ratio here because this is in grams. And if this is in grams and I need to use a mole to mole ratio, that means this step right here has to be a grams to moles step. And a grams to moles step is simply a molar mass. So this is a molar mass step right here. I don't know what SO2 weighs. Sulfur weighs 32, I believe. I gotta go look it up, 32.1, and oxygen weighs 16, so our total mass here is 64.1 grams is 1 mole. And again, I just got those by looking up at the periodic table. 32 and 16 gave me 64, so hopefully I didn't do that wrong. So now I'm in moles of SO2. Next step is going to be cross it down. So this is going to be moles of SO2. And as soon as I'm in moles, that should be the hint, like, okay, now I'm in moles, now I can use my mole to mole ratio. And this is the big one that we're always going to use in the middle of every single equation. Moles of SO2, now I can convert to the other chemical, which is going to be moles of O2. Why did I pick those? Again, because those were the ones that we're looking at in the equation. If I'm looking at SO2 and O2, this has to be SO2 and O2. That's going to be my mole to mole step. So looking at that equation right there, I've got 2 moles of SO2 reacts with 1 mole of O2. And again, why? Because those are our coefficients from our balanced equation. That's our mole to mole ratio right there. And then the last step, it's asking me for grams, so I got to do one more step. Almost there, because this is not grams yet. This is in moles of O2, if I did that right there. So I don't want to do that. So that means I have to go from moles over here, switch colors, to grams of O2. And again, with this one, I happen to know that oxygen weighs 16. This is a molar mass step again. So this is 1, and this is going to be 32. 16 plus 16 gives me that mass. So now when we math this all out, 3.75 times 32, and then it's going to be divided by 64.1 times 2. So again, make sure that when you're doing this sort of thing, when you've got 2 numbers on the bottom, divide by each number or enter them in parentheses, one or the other. So I'm going to hit it with my calculator, 3.75 times 32 divided by 64.1, and then I hit divided by 2 to make the number work out. And my answer was, I'll write it up here, 0.936037, and it kind of keeps going after that. So that would be grams of O2. Sig figs looks like we have 3 sig figs again, so 0.936 grams of O2 would be my final lovely answer. This is about as hard as it gets here. If you can write the equation and balance it, and then be able to kind of move through your series of steps, then you're in really good shape. There's kind of a rhythm to these. So the rhythm is always grams to moles, moles to moles, moles to grams. It's a molar mass step, then it's a moles to moles step, and then it's another molar mass step. If I could talk, that'd be easier. Kind of a rhythm that we get to. So last one, in terms of kind of the review, overview, what it is that we're working on. When you're attacking these problems, here's the steps that we went through. I kind of talked through it, but just as a way, if you want to write it down and have it in one spot, here's what you always do. Number 1, make sure that you have a balanced chemical equation. You might have to write it first. Might be given to you. It just depends on the level of difficulty. For the easier ones, I'll give you the balanced equation, but you got to always check to make sure that it's balanced first. Second thing is start to identify what it is that you're trying to find. What are the 2 chemicals that you're actually interested in? It will always only be 2 chemicals that you're interested in. So that's that key mole to mole ratio. Those are the balanced chemical or balanced coefficients from the chemical equation. And then the third thing is you're going to do your wonder fraction. Depends, how wide or how long that wonder fraction is, kind of depends on what units you're in. If you're starting with grams and ending with grams, those are the longest ones, but you don't necessarily have to do that every single time. So again, you're always going to start with whatever you were given, the quantity in the moles or units goes in that first step. You're going to always focus on crossing down units to make sure that you have it set up correctly. And then in the end, you're going to make sure your last step is at the right compound. Convert it to the one that you need or the one that you want at the end. When you do your mole to mole step, you're always going to use those coefficients to do the mole to mole step. And then if you need to, depending on if you've got grams, you may have a molar mass step or 2 molar mass steps in there. And then the math last. Remember, multiply everything across the top, divide by everything on the bottom, and you're set. So there you go. Practice problems. I hope that you had some success with this, and I'll see you in class tomorrow.